Wow, it's another time. I would like to take this opportunity to welcome you into the moment of learning advanced pure mathematics combinations with basic engineering mathematics. My name is Mwl Olenjolai. I would like to take this opportunity to welcome you. I have some physical students who are pursuing ordinary diploma in electronics and telecommunication engineering. I'll be just teaching you a cross-cutting concept, which we are teaching ordinary diploma students, especially NTA level 4, and also we are teaching advanced secondary students, especially the 6th chapter that's called Algebra in physics, or we call this advanced physics, or advanced pure mathematics. So you have to be concentrating. We'll be using the simple language to simplify the concept. Mathematics is the actual queen of engineering, and if you wish to be an engineer, then this is a very important moment. I would like to take this opportunity to welcome you in one of the college where we are training ordinary diploma students that's called TANZANIA Online Full Technical College. And also, I would like to take this opportunity to welcome you into our online school for A-level students that's called TANZANIA Online A-level Circuit School. This is the chapter, sometimes we call it Algebra for the pure advanced mathematics, and we call it matrices for ordinary diploma students. And this is all about linear algebra. We are going to focus on lecture 2. That's about determinants of the matrices, which will be focusing 3 by 3 matrix. So our main focus will be, we have defined the size of the matrix, 3 by 3 matrix, okay? However, that we'll be discussing, or we'll be starting with the introduction concept, but actually be diving on the 3 by 3 matrix. So I have some physical students. I want to appreciate them. Then we have to start. How are you? How are you, engineering students?
We are fine.
Well, are you ready for the algebra, to learn about algebra?
We are ready.
Yeah, so the module is called the algebra. I forgot here to write the module or the subject for A-level student. This is the topic in A-level, not a subject. It's a topic. So module or topic is called the algebra. Then let us discuss some concept. Let us start with abstract concept, then we'll go further and further. We have a word called the matrix. Say matrix.
Matrix.
Say matrix.
Matrix.
So this is singular. Plural is called the matrices. So the fundamental question, we need to know, what is matrix? Let us remind ourselves, what is matrix? However, our main concept will be focusing on on determinant of the matrices. What is matrix? Say matrix.
Matrix.
So you say a matrix is the rectangular arrays of the numbers. So a matrix is the rectangular arrays of numbers. So this is the rectangular arrays of numbers, rectangular arrays of numbers, or other mathematical object, other mathematical objects. Other mathematical objects, and these numbers has to be arranged in what? In columns and the rows. In columns and what? Rows. So a matrix is the rectangular array. Say rectangular arrays.
Rectangular array.
So a rectangular array of 40 numbers. Or other mathematical objects such as statistical data. And then these numbers or mathematical objects should be arranged in columns and the row. In columns and rows, or in columns only, or in rows only. Depends to the type of 40 of the matrix. So actually this is the style of arranging numbers in what? In columns and the row. So this might be a vocabulary. When you talk about rows, it means you arrange things that horizontally. So these we call them rows. Say rows.
Rows.
So you arrange things horizontally. And then so if you arrange things vertically, this in mathematics call them columns. Say columns. So columns means vertical, y-axis. Rows means horizontal or x-axis. Are we together?
Yes.
So examples of matrix before we discuss about T types, and then focus on the determinants of 3 by 3. Examples of matrices. The first example, we have a 2 by 1 matrix. Say 2 by 1 matrix.
2 by
We
1.
represent the matrix, so you say that the presentation of matrix is actual. We use represent matrix as rows times columns. Say rows times columns.
Rows times.
Say rows times column.
Rows times.
So the number before multiplication signs is called the rows. So that will represent the number of rows. And this one represents the number of 40 columns. So if you have 2 by 1 matrix, what does it mean? How many rows do you have there?
2 rows.
Class, I say the representation of matrix is rows times columns. Say rows times columns.
Rows times columns.
So if you write 2 by 1, this represents 40, number of 40 rows. And this represents number of 40
columns.
Are you together?
Yes.
So example, 2 by 1 matrix, it's 40. It's a matrix that has what? Is a matrix that has maybe it has 2 rows and 1 column. So row number 1, row number 2, 1 column. Customers? Let me repeat for customers. We say this is 2 by 1 matrix. Number of rows, how many rows do you have? 2. How many columns do you have? 1. So this is the first row, second row, but 1 column. Okay?
Yes.
So if we have been asked to write a 1 by 2 matrix. So a 1 by 2 matrix, it has a 1 row and how many columns?
2.
So example 4 and then 6. So you have 1 row, 2 what? 1 row, 2 what? This is important because when we're dealing with the determinants or inverse of the matrices, we have to think about rows and columns. And you have to understand them in order to understand the concept of finding determinants, finding cofactors, finding or transposing a matrix or find the inverse. Then a third example of the matrix, we can have 2 by 2 matrix. With this one we call T square matrix. So what does it mean? How many rows do you have here? How many columns do you have here? 2. So this is A, let's say B, C, D. First row, second row. First column, second column. Are we together? Yes. Again, we can have a 2 by 3 matrix. How many rows do you have? How many columns do you have? 3. So what do you expect? Maybe A, B, C, D, E, F. First row, second row. First column, second column, third column. Are we together? Yes. Make sure that next time you have an exercise book special for algebra, because I will teach you algebra the entire semester. And we'll be solving so many questions as well as we can. From the past papers of test 1, test 2, from Pure, the book that's called Pure Mathematics by Backhouse, Pure 1, Pure 2. We'll be solving a number of questions to make sure that you become competent before your final exam. Then we may be asked to show 3 by 2 matrix. How many rows do you have? 3 rows. Then 2, let's say 5, let's say 7. These are 3 rows, right? And how many columns? We can have 4, we can have 8, we can have 8. So this is the 3 by 2 matrix. Are we together? Then number 6, it's what we say that 3 by 3 matrix. So 3 by 3 matrix, how many rows do we have? 3. How many columns do you have? 3. So for instance, can have 1, 2, 3, 4, 5, 6, 7, 8, 9. Write down, write down. Mathematics is mastered by writing down on your own hand. You cannot read mathematics as how you read history. Mathematics is being learnt by writing, by doing. Okay? Okay? Yeah, so you should not wait the notes and then say, let me read as a literature review. No, 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 no. Okay, then another point, our main focus right now, or our focus, we have learned about 3 by 3, because in O level, we learned about 2 by 2 matrix. Do you remember? And we use 2 by 2 matrix to solve 2 unknown simultaneous equation. In A level and ordinary diploma, we have to teach about 3 by 3 matrix, and we will be teaching you how to solve 3 simultaneous equations with 3 variables, x, y, z. Okay? Class, are we together? Are we together? Yeah. So that is the important point. And another point before we discuss about determinant, I would like just to say about types of matrices. Let us just remind ourselves and understand about types of matrices. Types of matrices. There are so many types of matrices, but I will give you 9 types. And this is the question which has been asked in a free final exam. So this is, we can call it example 5, let's say, example 5, and refer the IT final exam of 2022-23, last year. It was question number, I don't remember the question number, but actually the question is, it asked you to mention 6 types of matrix. And you have been given a promise that if you do so, you will score 3 marks. Okay? So mention 6 types of what? Matrix. It was section A. I think question 1, Roman F, something like that. But it was question A. Mention 6 types of what? Of the matrix. So it's better for you to know the types of matrix. And you should not cram. It's easier to know them and to remember them. The first type of the matrix is called the row matrix. Say row matrix. Say row matrix. So a row matrix is the matrix which has only row. It does not have column. It has a single, so it means that all the elements are represented in terms of what? Row. For example, this one we call it row matrix. Say row matrix.
Row matrix.
So this is just a single row. You can have 2 elements or 3 elements in rows, or 5 elements or 6 elements, etc. Then the second type is called the column matrix. Say column matrix. So column matrix. So a column matrix is a matrix which consists of more than one row but single column. Hello, students, stop writing, stop writing. It's simple to identify. There's no need for you to just memorize this. Stop writing. A row matrix, say row matrix. It's a matrix which has a single row but multiple columns. For instance, this one. How many rows do you have here? Only one. How many columns do you have? 1, 2. Right? 2 columns. We may have 3 columns. We may have 4 columns. We may have 5 columns. But single what? Row. So that matrix we call it row matrix. Or some we call it row vector. We have row vector and column vector. Class, are we together? Yes. Column matrix, it has what? A single column, multiple what? Rows. Just like this one. Single column. First row, second row. Okay?
Yes.
Because sometimes, maybe in a test, maybe as you mentioned 60 types of the matrices with examples. Then the third one is called the square matrix. Say square matrix.
Square matrix.
So a square matrix is a matrix in which the number of rows and column is the same. Ni matrix ambayo idadi ya namba ambazo ziko kwenye mlalo ni sawa na idadi ya namba ambazo ziko kwenye nini? Wima. Mfano, example, this is a square matrix. Hello, look here. How many rows do you have? 1, 2. How many columns do you have? 1, 2. So that is a square what?
Matrix.
It's 2 by 2. It's a square matrix. Then we come for this case. 3 by 3. It's a square matrix. How many rows do you have? 1, 2, 3. How many columns do you have? 1, 2, 3. Are we together?
Yes.
Another example of square matrix, 4 by 4. Say 4 by 4 matrix.
4 by 4 matrix.
We'll have 4 rows and 4 what? Columns. Another example for square matrix, 5 by 5. How many rows are you going to have? 5. How many columns are you going to have? And I want to tell you that in advance, whether you are ordinary diploma student or you are A-level student, when you learn this concept, keep in your mind, because you will apply or you learn this concept and revise it and actually advance it in undergraduate or bachelor degree, and even in master's degree or in PhD of engineering. For instance, if you are pursuing any master degree in engineering or any PhD in engineering, you will be referring and you will be applying matrices to solve real-life engineering problems. So you should not learn because you need to pass the exam. You have to learn and remember these fundamentals, because when you get into the higher level, we don't repeat this concept. We actually advance. Are we together?
Yeah.
For instance, in my master's studies, we are learning how to solve 8 by 8 matrix. 8 by
8 matrix.
Do you know 8 by 8 matrix? Once you write those elements, you can fill all of this column, all of this part. 8 by 8 what?
Matrix.
And then you have 8 simultaneous equations. Not 2, not 3, 8. And those 8 simultaneous equations represent a particular situation in real life. They have meaning. So you may solve and achieve to solve the real life problems. You may solve and have a mathematical solution, but it's not equivalent to the real life problem. Hello? So when you learn this concept, make sure you keep in your mind. After you pass the exam, keep in your mind. Keep the exercise book that you'll be using to write. Okay?
Yes.
If somebody needs, ask him or her to make a copy of them. Remember what I'm telling you. Then, the first types of the matrix is called the identity matrix. Say identity matrix.
Identity matrix.
Say identity matrix.
Identity matrix.
Then another type of matrix is called the zero matrix. Say zero matrix.
Zero matrix.
Say zero matrix.
Zero matrix.
Say zero matrix.
Zero matrix.
So you have zero matrix, we have identity matrix. It has some characteristics, that's why we call them identity matrix. And also we have the 6 types of matrices. We call it symmetric matrix, or we have triangular matrix. Say triangular matrix.
Triangular matrix.
Say triangular matrix.
Triangular matrix.
Then number 7, we call it symmetric matrix. All of these matrices have a meaning, and we apply a number of them in solving real life engineering problem. Then the 8 types of matrices is called the idempotent. Matrix. Then the other one, number 9, is called the singular matrix. Say singular. Say singular matrix.
Singular matrix.
Say singular matrix.
Singular matrix.
And then number 10 is called the non-singular matrix. Non-singular matrix. So you've been asked to mention 6, you know 10. Will it be a difficult question for you? Class, say row matrix. Let us reinforce understanding. Say row matrix.
Row matrix.
Column matrix.
Column matrix.
Say column matrix.
Column matrix.
Identity matrix.
Identity matrix.
Square matrix.
Square matrix.
Zero matrix.
Zero matrix.
Triangular matrix.
Triangular matrix.
Symmetrical matrix.
Symmetric matrix.
Idempotent matrix.
Idempotent.
Singular matrix.
Singular matrix.
Non-singular matrix.
Non-singular matrix.
The next one. Good luck. Are you just writing? You don't say? You're just writing. I will chase you in my class now. Okay. So then we say that we call them basic operation of 3 by 3 matrix. Say basic operation of 3 by 3 matrix.
Basic operation of 3 by 3 matrix.
So the following are the 5 basic operation of a 3 by 3 matrix. The first one, so all the ladies have gone out. All the ladies have gone out. So I have gentlemen in this class. Wow. So they seem like they know. Okay. So the first one is called the addition. Say addition.
Addition.
2 matrices can be added together. And when we add the 2 matrices, we have to add the elements. Then the second basic operation is called the subtraction. Say subtraction.
Subtraction.
And the third one is called the scalar multiplication. We cannot multiply the matrix because of the condition, but we can do scalar multiplication, where we take a number, we multiply with a matrix. Okay?
Yes.
Then the first important operation that we are going to discuss today is called the determinant. Determinant of the matrix. Determinant of the matrix. Say determinant of the matrix.
Determinant of the matrix.
And after that, number 5 is the last one. Inverse of the matrix. So you can find determinant of the matrix. We can perform scalar multiplication. We can perform subtraction. We can perform addition. We can also find the inverse of what? Of the matrix. So today we'll be focused on determinant of 40 of the 3 by 3 matrices. Determinant of 3 by 3 matrix. So what do you mean when you say that determinant? So determinant, this is a very important operation that we need to know in a matrix, so that we may also find some other, the inverse operation. So simply say a determinant of the matrix is the magnitude of the matrix. In mathematics, we donate determinant by using this symbol. So this is the symbol for the determinant. This is the symbol used to do notation of the determinant. We don't spend much time discussing about determinant because you have a foundation of it in O level or in ordinary secondary education. We'll be actually focusing on how to solve the determinant of the 3 by 3 matrix. So if that's the case, you say that the general form of 3 by 3 matrix is this one. Separating is this one. Separating A11, A12, A13, A21, A22, A23, A31, A32, A33. Look, this is the general notations of the 3 by 3 matrix. Suppose that the name of our matrix is matrix A. Say matrix A.
Matrix A.
Say matrix A.
Matrix A.
And remember that from A11 up to A33, these equal terms are the elements of the matrix. Say elements of the matrix.
Elements of the matrix.
So what the meanings of this subscript? Listen and look. These subscripts have a meaning. Okay? The first subscript represents the number of rows. How many rows do you have there?
3 rows.
A row number 1, row number 2, row number 3. Okay?
Yes.
So the first subscript represents Oya Simba. Represent what? The number of rows. So this is the first row. This is the first row. That's why we have number 1. Oya Mamba unaandika. And this one still row number 1. Right?
Yes.
This one row number 1. This one element in row number 2. This one element in row number. This one element in row number A. This one element in row number
3.
This one element in row number
3.
This one element in row number
3.
The second number represents column. This is first A.
First column.
This one second column. This one
Third column.
that's why we have A12, A13. This one A
First column.
first column. This one,
Second column.
this one,
Third column.
and this one.
Third column.
You just say third because you are crazy. And this one,
First column.
and this one.
Second column.
This is the second column.
In the third row. Third row.
Third row. This one,
Second column.
A.
Second column.
This one,
Third row.
this one.
Third column.
So this is the element in the third row or third row and third what? Column. Are we together?
Yes.
Are we together?
Yes.
Are we together?
Yes.
Then, if that's the case, we say that, for instance, if you want to write the determinant, then you say determinant of matrix A is equal to magnitude of what? Of A. Determinant of matrix A is equal to the magnitude of what? A. Magnitude of what? Of A. So if you find that the question has been given a matrix, it can be numbers or letters. You know that there are some letters and sometimes it depends. Some of them are very challenging and we'll deal with them, right? Because those are the questions that will be asked in the exam. But if you've been asked to find this, it means you've been asked to find what? Determinant. Are we together, class?
Yes.
Remember that this is the first what? Column. This is what? Second what? This is what? This is what? This is what? This is what? Very important. Especially in finding or in dealing with what? Determinant. Are we together?
Yes.
So to find determinant of the 3 by 3 matrix, we are supposed to delete some columns and rows in the 3 by 3 matrix to make minor matrices or minor matrix. Say minor matrix.
Minor matrix.
So a minor matrix is actually, we say it's a result after deleting some columns and rows of the higher matrix. For instance, a minor matrix of 3 by 3, it's 2 by 2 matrix. A minor matrix of 4 by 4, it's 3 by 3
Matrix.
A minor matrix of 5 by 5, it's 4 by 4
Matrix.
Class, are we together?
Yes.
That's the trick. So before we deal with determinant, we have to know the meanings of minor matrices. So minor matrices before we deal. Say minor matrices. Say minor matrices.
Minor matrix.
Sometimes maybe given a matrix, then you'll be asked to find the minor matrices. That's all. So a minor matrix or the minor matrices are the matrices obtained from the higher matrices by deleting what? By deleting one row and one column. One row and one column to obtain a one row and one column. Let's say that of the heart to obtain a lower or a minor, or to obtain what? A lower matrices. A lower matrices. So minor matrices, these are the matrices obtained from higher matrices. Say higher matrices.
Higher matrix.
Example of higher matrices for our case is 3 by 3 matrix. By deleting one row and one column to obtain a lower matrices. Example of lower matrices for our case is 2 by 2 matrices. Okay? Class, are we together? Do you understand? Yeah, so bear that minor matrices is very important. So you say that a determinant of 3 by 3 matrix is found by finding 3 2 by 2 minor matrices. That's all. So the determinant of 3 by 3 matrix is found by finding 3 2 by 2 matrix. Stop writing. This is the 3 by 3 matrix, right?
Yes.
To find the determinant, we have to use these 9 elements, 1, 2, 3, 4, 5, 6, 7, 8, 9. To find 3 2 by 2 matrix. Right?
Yes.
And I will show you how we do so. So, if that's the case, we say that from matrix A, and then we have our elements A 1 1, then A what?
1 2.
Then A what?
1 3.
1 3. Then you have A what?
2 1.
Then A what?
2 2.
Say it loudly. A what?
2 3.
Then you have A what?
3 1.
Then A what?
3 2.
A what?
3 3.
3 3. So listen carefully. How do we find minor matrix? Simple. For example, you can delete the first column and first row. We remain with 4 elements. This is a 2 by 2 matrix. Let me repeat. How do we find minor matrix? Ask your neighbor, how do we find a minor matrix?
How do we find a minor matrix?
We have to delete 1 column and 1 row of 3 by 3 matrix. So listen. For example, we can delete this column and this column. Let us delete this column and this column. We remain with how many elements?
4 elements.
1, 2, 3, 4. So we can call that, for this case, we have A22, A23. And this one, we have A32 and we have A33. So this is a minority. This is the minority matrix. It is 2 by 2. It has 2 columns, 2 rows. Are we together?
Yes.
We may also find another minor matrix. Say subwriting. Another minor matrix by deleting the first, the second column and the second row. Are we together?
Yes.
What are the elements that we'll have? A 1 1 and
A 1
A 3 1 and A 1 3 and
A 3 3.
A 3 3. That's all. This is the minor matrix. It's 2 by 2. Class, are we together?
Yes.
Right now we are using letters, but later we'll be using numbers and variables. We may also find a minor matrix by deleting the third row. That's why you have to listen and you have to understand and say the column. Right? Say the row and say what?
Column.
How many minor matrices do you have? And so all the elements that we have. A11,
A2 1.
A12, then
A2 2.
A2,
2.
A, and A what?
A2 2.
A22. That's how. Is it clear about minor matrix? That's the secret of understanding determinant and secret of understanding inverse of 3 by 3 matrices. It's just the ability of finding minor matrices. For the determinant, we are just going to use only 3 minor matrices. When we find the inverse of 3 by 3, we have to find 9 minor matrices. Are we together?
Yes.
Are we together, class?
Yes.
Yeah. A question about minor matrix, is it clear? Is it clear?
Yeah.
Yeah. So if it's clear now, let us use this understanding of minor matrices to find determinant of our matrices. So suppose that a be given matrix A, this is equal to what? Is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. Then let us find what? Determinant. Let us find determinant of matrix A. So to find determinant of matrix A, we have to use the concept of minor matrix, and also you have to use the concept of plus and minus. Yeah, I understand. Don't worry. It's nearby Tanzania time, don't worry. I will take consideration of you, right? Yeah, I will not let you down. You will understand minor matrix, but you feel hungry. The whole day. So listen. So we are going to use two concepts. Separating, please. We have been asked or we want to derive the formula of determinant. Say determinant. Determinant of A. We are going just to use two simple concepts. Hello? We are just using only two simple. The first one is placing positive and negative to some of the elements in that 3 by 3 matrix. And that is the first concept. This first element of 3 by 3 will put it the sign of plus. This is positive. So it will be positive A11. Okay? Hello? Hello? Then for the second element, in first row and second column, we are going to use, or we are going to introduce a negative sign. And for the third element of the first column and third of the first row and third column, we are going to use a positive sign. That's the first concept. So we are writing this sign on top of them, but when we be writing or formulating the minor matrix, this sign will be positive, negative, positive. Are we together?
Yes.
Are we together, class?
Yes.
That's the first concept. And the second concept, you have to formulate 3 minor matrices. Okay? So the first one, we'll see that. We'll delete the first column and first row. We get the first minor matrix. The second one, we will delete the first what? The first row and second column. We'll get our second minor matrix. The third matrix, or the third minor matrix, we delete the first row and third what? Column. Then after that, we just define determinants of 2 by 2 matrix. Then we are done. We have determinants of the matrix. Let me write what I've been saying. Determinants of the matrix will be what the sign of the first element?
Positive.
Positive. Positive what? A1. Okay? Then next, we will delete elements of the first column and the elements of the first row. Right? What will be our minor matrix? Say it loudly. A22, A3, A2, A31, right? A32, and the A33. This is our first minor matrix. Then we move. What sign we did introduce for the second element? Negative. We have negative here. Negative what? A1, 2. Then we are going to formulate our second minor matrix. What is our second minor matrix? We always delete in the first row. Yes. What will we delete in the first? And we have deleted the second column. Okay? So you delete the second columns. What are the elements that we remain with? A11. A11. A21. 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 Thank you very much. And the A31. A2 and the A33. Okay? Okay? Next, what's the sign of the said element? Positive. So we'll have plus. Plus A what? 1, 3. Okay? A. We are going to formulate the what? Another minor what? Matrix. Okay? We always delete the first row. So you have to delete the second, the third what? Column. So if you delete the third column, what do you get? A21, A2, 2, 2. And then A31, A32. Then we are done. We have 3 minor matrices. Okay? Then the next process, this will be the first step. Find the minority. Find the minority. Minor matrices. The second step, separating, just listen. Find what? Determinant. Find what? Determinant of minor matrices. And find the determinants of minor matrices. It's simple. What is it? You just take the main diagonal minus what?
Leading diagonal. Leading diagonal.
Plus, this is the main diagonal, isn't it?
Yes.
And this is the main diagonal, right?
Yes.
And this is the main diagonal, right?
Yes.
This is minor diagonal, minor diagonal, minor diagonal. Okay? Yes. So determinant is equal to what? Positive A11, because sometimes the elements you may find is negative. Then we open bracket like this. Main diagonal is what? A22 times what? A33, right? A minus what? A23 times what? A32. Okay?
Yes.
A minus A12. Then you have what? A21 times what? A33 minus what? Say it loudly. Matrices. A13, right? Then you have what? A21 times what? Minus what? A, then minus what? That's all. So if you have the numbers or the variables, so remember that sometimes we give you letters, so we give you variables and numbers, and we ask you to find the value of that element. And sometimes it depends on the format. Some of them you may do, or you may solve even 15 minutes at a time you can find the variable. Are we together?
Yes.
So if you need to find the determinants, you just have to follow 2 steps. From here you just need to subtract, multiply. 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 Class, is it clear?
Yes.
Yeah, so if that's the case, join me in the next lecture, lecture 2, 3, when we'll be doing examples of finding determinants of 3 by 3, and then we'll be solving some questions, which conceptual questions. We'll be solving some questions from past papers. So make sure that you don't miss it, and we'll enjoy this concept. And actually, I think that we'll master it. But also in that lecture, I will teach you how to use a scientific calculator to find determinant of the matrix. So make sure that in the next class, you have your scientific calculator. However, that if you be given a question, the scientific calculator will just give you the confirmation whether the determinant that you found is correct or not correct. That's the goodness of scientific calculator. But you have to do it. Because if the questions will have 4 marks, those 4 marks will be split on the solution. And this is the solution. So make sure that in the next lecture, you come with a scientific calculator, then I will teach you, and I believe that you'll enjoy it, so that, yeah, did you understand? Yes. Did you enjoy the concepts of 3x3 matrix? Yes. Wow. So it's better to congratulate you. Now it's time to congratulate you. 1, 2, 3. Hongera matrix. Imara mwanafunzi. Wow, engineer. Thank you very much. May God bless you.
Yes.
Mungu